everyone, my name is Devraj Karmakar. I am a second year MSc student at IIT Kharagpur. I am currently pursuing my degree on mathematics. Today I will give a lecture on complex numbers. Today I will first describe what is a complex number system. Then I will give some properties, basic properties to start with of complex numbers. Then I will define what is a modulus and the argument of a complex number, and some properties related that. Then I will give an example of some questions, and then I will see, then I will tell what is the rotation of complex number and various things. Let me first start with the complex number system. Now we know what is a real line, right? This is a real line. It consists of integers, and every actually it consists of rational numbers and irrational numbers. Now, why do we need the complex numbers? Actually, why we need the complex number? We know if x belongs to R, then x square will always be greater than equal to 0. But then we are empty-handed with the equation here, that then this equation doesn't have a solution in the real line for any x. But that's why we need an imaginary number I that will satisfy that equation, that is f of I equal to 0. That means I square equal to minus 1. That will give us I equal to root under minus 1. Now I hope that is clear. Now where do we put that imaginary number? Because we know the real line doesn't contain the solution of this. Then we need to make an imaginary axis. Let me pardon for my drawing. Now, where as we know that we doesn't have a solution for the equation, for that equation x square plus 1 equal to 0 for on the real line, but we made an imaginary number I that will be the solution. Then where should we put that number? We have to make an imaginary axis for it, where we will put I, and the distance here actually, and the distance here, this distance is same as the distance between 0 to 1. And similarly there I will make minus I minus y here plus 2i, where the distance is the same as 2. Now this is called an Argand plane, where it has similar properties with R square, where every a comma b will be related to a plus ib, right? Because we are assuming that is A, that is B. Now then what we got, here is a real number and here is a real line and there is a imaginary line. Now that completes our complex number system. Now the I just we recently discovered that has some nice properties to begin with. Like we know that I is root under minus 1, that is basically I, and I square equal to minus 1. Then I cube is I, we can break it into I square into I, that will be minus I. Then I to the power 4 will be I square into I square, that will be 1. Like minus 1 into minus 1, that will be 1. Now that values of I square, I cube and I to the power 4 will repeat itself just like this one. I to the power 5 we can write it again it I to the power 4 into I, that will be equal to I to the power 6 equal to I square. That we can see a pattern here, right? Like I to the power 7 will be I cube, that will be minus I, and I to the power 8 will again equal to 1. Now we know that any natural number in M belongs to natural number if every natural number can be written in the following forms, right? 4n plus 1, 4n plus 2, 4n plus 3 for some n, because this is the modulo property, nothing else. Now we have an interesting thing here, that I to the power 4n, I to the power 4 to the power n, that will be 1 to the power n, that will be 1. Now I to the power 4n plus 1 will again be I to the power 4n into I, that is we got I to the power 4n equal to 1, that will be I to the power 4n plus 2 will be I to the power 4n into I square minus 1, 4n plus 3 equal to I to the power 4n into I cube I, that will be minus I, right? We see that these values are keep repeating. Now there are many questions based on that only. Like if you take summation j equal to 1 to summation, there are many questions based on. Now there are many questions based on that property only. Let us, there are many questions based on this only. Let us see some of that. Like 1 to 15 I to the power n, right? We have to know the value of this function, this we have to know the value of this number. Now we have seen here that every value is keep repeating after 4 terms. Then if we can get the value of first 4 terms, that will repeat itself. Then first we get the value of I plus I square plus I cube plus I to the power 4, that will give us I minus 1 minus I plus 1, that will give the aggregate value of 0, right? And we can pair these up for every 4 times, because the I to the power 5 plus I to the power 6 plus I to the power 7 plus I to the power 8 will be again be a 0. Then we can divide that 15 into 4 each equal parts. For each 4 tuple, it will give us 0. Then what are we left with? We left with that 4 plus, we can give a partition of 15, that 4 plus 4 plus 4, that will give us 12. We are remaining with 3, and we can see the table here. Just we got, then we are writing as, it is basically I plus I square plus I cube, that will give us minus 1. Now let us see what are modulus and argument. Those are very important concepts in complex number. Many questions are regarding this only. Now we first have seen that what that if that is a point a plus b I b, then the height is b, the base is a. The modulus is nothing but the distance from the origin to the number. Like now I have previously told that the Argand plane is similar with r square. Now we know the what is the distance between a point AB from the point 0, right? Now we know what is the distance between a point and the origin, right? That is a minus 0 whole square plus b minus 0 whole square, that is root under a square plus b square. Now this is called mod z, and this is called the modulus of z. Now for the real line, let us say that it is 5, this is minus 5. Now for the real line, the modulus is the usual mod that we say for the real line, right? Because the for minus 5, the distance from the origin is 5 units. That's why minus mod 5 is usually equal to 5, and similar cases. And what will be the mod of I then? When I have told that I is defined to be in at the same distance at what is 1 at, then mod of I is distance between 0 to I, which is same as distance between 0 to 1. Then mod of I will be defined to be 1. Nothing like, right? Now what is an argument? Let me take a point a plus ib. Let me draw a straight line from 0 to a plus ib. Then the angle theta that is coming here is called the argument of z, and is denoted by argument of z equal to theta. Now if here I am taking a plus ib as a point in the first quadrant, then we can, by using trigonometry, we can easily get what is the point, what is the angle theta, because we know the base is of length a, the height is of length b. Then what is theta? We know theta is, we know what is tan theta, right? Tan theta equal to height by base, that implies theta equal to tan inverse b by a. So that's the basic of complex numbers. I hope I am able to teach you. So thank you for today.